Okay, next question. So an ideal monatomic gas is kept in a container of volume 2.1 into 10 to the power of minus 4 pW. What is given? Temperature T is given over here. Pressure T is given. State what is meant by an ideal gas. What do you mean by an ideal gas? Some answers mention that a gas that obeys ideal gas equation. Gas that obeys ideal gas equation is an ideal gas. You are absolutely correct. Okay, there's nothing wrong. You can write like this. Okay. The second kind of definition you can say is that, because one of the assumptions of ideal gas is that the gas molecules present in it are like identical marbles. They keep on moving, they do not stick to each other, right? Which means there is no intermolecular forces between the molecules. Okay, so you can write this also. Then you can also say molecules have zero potential energy. They have only kinetic. Okay, any of these three assumptions you can write. Okay, there are 7 assumptions totally for the ideal gas, but what you can do is you can just mention any of this. Only one of this is fine, because you have only for 1 mark, only one of which is fine. Next, calculate the number of atoms in this gas. Now, how do we work on this? So we know that since an ideal gas, we can write PV is equal to nRT. Right? This is something which is known to us. What is N? N is the number of moles. What is it I need? I need the capital N only, right? So we can also write this N as capital N divided by Na into R into T. Or I can also write this as equal to N into R by Na into T, which can again be written as capital N into, what is R by Na? K, Boltzmann constant, multiplied by T. So we have got the value of N here, right? So now what we will do is we have to take this N as subject to I will write N is equal to PV divided by KT. Though this derivation has not been asked, but if you want to know, I'm just writing this over. So what is P? PP is given here. Okay, so I will write this as 5.3 into 10 to the power of 5 multiplied by volume. What is volume? 2.1 into 10 to the power of minus 4 divided by, what's the value of K? 1.38 into 10 to the power of minus 23 multiplied by temperature. What is the absolute temperature? 310. Okay, remember, in thermal physics, everything should be in Kelvin only. It should not be in degree Celsius. Okay, now let us calculate what is this value. Okay. So this should be 5.3 multiplied by 2.1 divided by 1.38 is equal to so much divided by 310. When I do this, I get 0.0260. Write this down, 0.0260 multiplied by 10 to the power of 5 minus 4 is 1. 1 plus 23 is 24. 24, which I can now write this as 1, 2. This will be 2.6 into 10 to the power of 22 molecules. 2.6 into the power of 22 molecules. You see, 2SF here. So therefore 2 significant things. Okay, 2.6 into 10 to the power 22 molecules. May write, don't forget to write the number of units over here. It should be molecules, no unit, but at least mention what it is. That's very important. Okay, next. Calculate and use the internal energy of the gas. How do you write the internal energy of the gas? Okay, so for one molecule, the internal energy is given by the formula 3/2 times K. Remember this. Okay, so one molecule, the internal energy is given by 3/2. If it is for 1 mole, then I write it as a 3/2 RT. Okay, I'll write down if you want that also. For 1 mole, I'll write this as a 3/2 RT. But if it is 1 molecule, 3/2 KT. Now, how many molecules we have in that gas? We have this much number of molecules. So therefore, it's asking you internal energy of the gas. So U of the gas is equal to 2.6 into 10 to the power of 22. So many molecules. Multiply this by 3/2 times KT. So let us do this. 2.6 into 10 power 22 multiplied by 3/2 multiplied by 1.38 into 10 power minus 23 multiplied by, what is the temperature? Temperature was 310. let us take all these values and then do the calculation so that we get the final answer. So I get this as 0.6 multiplied by 1.38 multiplied by 3 10. I get this as 1122 1111112 so like 112.3 into I missed something. Did I include the 3 by 2? I didn't include the 1. Forgot this one. Multiplied by 1.5. 3 by 2 is 1.5. So I do this, I get 1668. Let me solve this. Therefore, 1668. We erase this part. I write as 1668 multiplied by 10 to the power of here 22. Here it is minus 23. It should be minus 1. Should be 166.8 joules. Two significant figures. I want one day in terms of how many significant figures. Let us look at this. This is a common thing everyone asks the exam. How many significant figures are given? There are only 2 significant figures everywhere. So I need to keep it only in 2. So I will write this as 172. One sum. Then next question: the volume of the gas in A is increased to 6.8 into minus 4 joule, minus 4 meter cube at constant temperature. Constant temperature. Volume is raised. Calculate in pascals the new pressure of the gas. We are using ideal gas. As long as you are using ideal gas, you can use P1 V1 is equal to P2. In fact, you can use it for anything also, any other gas. In real gas also you can use. Okay, in an ideal gas you have to use PV equal to nRT. Okay, but if it is not an ideal gas, you can use this also. Okay, now P1 V1 equal to P2 V2. Now what is being given? This is your new V2. This is your new V2. Do I have, what is it you need to find? You need to find the value of P2 here. I need to get the value of P1 and V1. Is it given to you? What's already given? Let us find out what is this once again. P1 was 5.394 minus 5 plus 5 and V1 was 2.1 into 10 minus 4. Let's write that one here. So 5.3 into 10 to the power plus 5 multiplied by, what was the volume? Volume was 2.1 into 10 to the power minus 4. 2.1 minus 4 is equal to P2 into what is V2? V2 is 6.8 into 10 power minus 4. So therefore, your P2 will become 5.3, 2.1 multiplied by 5 minus 4 is 1, then divided by 6.8 into 10 to the power of minus 4. What will happen now? Let's calculate that also. So this will be 5.3 when I get this as 1.64 into 10 to the power of 4 units pascals. Okay, so this is what happens. See, here it is 5.3 10 to the power plus 5. Here it is 1.6 into 10 to the power plus 4 pascals, which means the pressure has reduced. Why should it reduce? Because you know what is happening to the volume over here. Volume was 2.1 into 10 to the power minus 4. Now need to take care of this one. 5 minus 4 is 10. 5 point. Let me put the answer here. Sorry, it's a power of 1. 5 is the power 5. I should get. There's a 10 here. I missed this. Let me redo this calculation. 1.1 then much divided by 6.8 is 16.36 into. Oh my God, that's what happens. This one here. Erase this and we write this once again. So I get the answer as 16.36 into 10 to the power of plus 4 pascals, which is equal to 1.64 into 10 to the power of plus 5 pascals. This is what I get. Okay. Next, explain in terms of molecular motion this change in pressure. Why do we have a increase in pressure, right? 5.3 and 1.64. Okay, so what has happened to this? Why does a decrease in pressure has happened? That's the question. So why does it happen? The first thing, what did we do here? Temperature is constant. Temperature is constant. Then what happened? Volume, is it increasing or decreasing? Let us look at this. What is the initial volume? 2.1 into 10 power minus 4. What is the final volume? 6.8 into 10 power minus 4. Which means what? 2.1, 6.8. 6.8 is higher than 2.8, right? So therefore, volume is increased. Volume is increased. And volume is increased, what happens? More space for the molecules to roam on, right? To roam on. Because earlier the container was only so much. Right? Earlier the container was only so much. Now you made the container just much. So what happens? Molecules can roam around freely. Okay. So because of this, what happens? Time taken for collisions is more. Time taken for collisions is more. Earlier, let us say one collision, another collision. It used to happen, let us say, in 2 seconds. Now it is happening something like 4.5 seconds or 5 seconds. If that is the case, now what happens? Because of this force to the walls lesser. It's less, right? When force is lesser, automatically pressure is low. See, you need to mention what you have found out here, otherwise you will not get money. Don't just mention when volume decreases, pressure decreases. Okay, there is nothing but in accordance with volume increases, speed decreases. In accordance with Boyle's law, you can mention that, but you won't get marks there. You might get only 1 mark over there, but you need to explain because the command term is explained. You need to fully explain. Okay, so with this, I think we'll come to an stop to this question. We'll see the next question tomorrow. Thank you.